today? Did you send me anything, or?
I didn't, but in class we've been working on just circle stuff, so.
Okay, I just got something from another student that probably applies perfectly to you. This one?
That looks right.
Okay. Me. Should we start from the top?
Sure.
Tell me a radius line.
Of what?
Of that diagram there.
Oh, okay. Radius would be k to f.
What's a common tangent?
Common tangent would be line AF.
Okay, what's a tangent line?
That'd be like line C.
CD. C is actually a point, but CD is that line. Okay? A secant line.
Would that be EH?
Correct? A center?
That'd be K.
And a point of tangency.
Huh?
A point of tangency.
That'd be like E.
Not E. It's either A, F, or C. Each of those are points where a straight line touches the circle in exactly one spot only.
Okay.
And a chord.
A chord would be like EH.
Now that's a secant line.
Oh, then...
Chord only goes from circumference to circumference.
Okay, so FJ.
FJ is actually a chord. It's also a diameter. A more common answer for chord would be GH. In other words, a chord doesn't have to go through the center. FJ goes through the center, making it a diameter. But the definition of a chord is any 2 points on the circumference that are connected by a straight line. So technically, the diameter is also a chord. Problem 10, or problem 9. What kind of triangle is that? And why?
That's a right triangle.
Why is it a right triangle?
Because the tangent of the radius makes a 90-degree angle.
Right. All tangent lines, when connected to the radius, make 90-degree angles, by definition. What's the hypotenuse length?
That would be 2 plus E.
What's that right there?
Looks like an E.
It's an R. And the only reason I know it's an R is because all radiuses are equal within the same circle. So if this thing down here is R, that has to be R.
Okay.
What's the hypotenuse length?
3 plus R.
Now let's solve for R. Apply the Pythagorean Theorem. you don't know it,
Okay.
memorize it. There are no theorems in geometry more important than the Pythagorean theorem. I would say of the entire 2 semesters that you've learned geometry, it's the most important thing to come out with. You're going to have to apply it 100 times between now and when you graduate. So get really good at knowing it.
It's just a squared plus b squared equals c squared.
Which in this case means?
R squared minus 5 squared equals...
Not minus.
No, r plus 3 squared.
Hold on. Let's start with the 2 short sides.
Okay.
That's equal to the hypotenuse squared.
Okay.
Now we have to solve this. What's the next step in solving that? Get rid of parentheses. If you are ever in doubt as to how to solve an algebraic equation, 2 excellent starting spots are get rid of denominators, get rid of parentheses, get rid of exponents if you can. Well, I can get rid of these 2 parentheses and that exponent by merely doing that operation. What is r plus 3 squared equal to?
R squared plus 9.
Most common error made in math, made by my previous student, will be made by my next student. Don't make it. R plus 3 squared means this. Now FOIL those 2 together. What do you get?
Oh, you get r squared plus r plus 6 plus 9.
R squared plus 6r plus 9. And it's another thing that you're going to have to do 100 times. So learn this, that a plus b squared is not a squared plus b squared. It's a squared plus 2ab plus b squared. There was the 2ab right there in the middle. The middle term is 2ab. But it is not r squared plus 9. And it really is true. I've read in math books that that's the most common error made in algebra, and 90% of my students make it. So, don't make it, okay? Now, what's the next obvious step I can do to simplify this thing?
Balance it.
There's something staring you right in the face that you can do right away that simplifies the equation.
Or you can
cancel that r squared with that r squared. Why? Because they are both being added to everything else. In other words, all I'm really doing is subtracting r squared from both sides, right?
Yeah.
Now you have 25 equals 6r plus 9. Solve that.
25 plus equals 6r plus 9. That is 14 or 15 plus equals 6r.
25 minus 9 is 16. So r equals 8 thirds. It's 16 over 6, which reduces to 8 thirds. Now, let's look at that and make sure that that makes sense as an answer. Yeah, it does. R could easily be a positive number, 8 thirds. That r is 8 thirds. That's going to work. In other words, we didn't do anything wrong in our mathematics. Okay, number 10 is almost identical. Let's see, you give me the equation on 10.
10 would be r squared plus 2 is equal to r squared plus...
Do both short sides first on the left side of the... Remember what the Pythagorean Theorem is. It's a squared plus b squared equals c squared. So don't mix that up. Always stay with that formula. Well, what are the two short sides?
R and 4.
Right. In other words, whatever is not the hypotenuse are the short sides. So r squared plus 4 squared, there's my a squared plus b squared. What goes on the right side?
Equals r squared plus 3.
No, we got to square this hypotenuse. What's the distance of that hypotenuse in 10? Not 9, but in 10.
R plus 2.
Quantity squared. Now we have a squared plus b squared equals c squared. Okay? And now, just like the last problem, we have to expand it and simplify. So, expand r plus 2 squared.
R plus 2 squared is r plus 2 times r plus 2.
Okay? Do that operation.
R squared plus 4r plus 2. 4.
4. And that's equal to r squared plus 16. Now what?
You could get rid of r squared on each side.
Which helps a lot, notice. In other words, right now we have a quadratic on the left, a quadratic on the right. When I get rid of the r squareds, all of a sudden I'm looking at a linear function. It's only going to have one answer. Subtract 4 from both sides. Divide both sides by 4, and you get r equals 3. 11 is a little different. Let's do that. It's actually easier. What equation can I write from 11? What do you know about two tangent lines to the same circle that intersect at a point outside the circle?
Not much.
Well, let's assume you didn't know anything at all. What does it look like they are?
Triangle.
That's not a triangle. We're trying to solve for x. So what PS, the line PS, compared to the line SQ, what do those look like? Are they equal?
Sides of equal sides.
Are they equal? Do they look equal?
Yes.
Well, that's a good guess. They are. Whenever you have two tangents that intersect outside the circle, and they're both tangent to the same circle, they're always equal. And notice that that's the only thing that would allow us to solve this thing. There's nothing else that makes any sense. There would be no way to solve it if those weren't equal. So sometimes that's helpful when you go to solve geometry problems. If you don't know that relationship, well, make an educated guess that sure looks equal to this. Let's set them equal to one another and we'll go about our business. And what's the solution here?
Well, you could add add 5 on both sides.
Okay. Turns that into a 12. Gets rid of that.
X equals 12.
Correct. Okay. So those problems are actually really easy. When they have two tangent lines, you just set them equal to one another and they solve quite well. 12, similar thing, but the algebra is a little more complicated. What's the equation?
9x squared plus x plus 1 equals x plus 5.
Okay, next step.
You could subtract x on both sides.
Next step.
Subtract 1 on both sides.
Okay, now you have this. Next step.
To find the square root of both of those.
Well, that's not entirely wrong, but it's not going to leave me with x. I want to isolate x, so what should I do before taking the square root of both sides?
Divide everything by 9.
Now you've got x squared isolated. Now if I take the square root of both sides, I'm going to have my answer. X equal what?
X equals the square root of 4 over 9.
Which is 2/3. Notice the square root of 4 is 2, square root of 9 is 3. However, you left out something extremely important. Whenever we are solving an equation by taking the square root of both sides, we have to begin our answer with plus or minus. So the answer is plus or minus 2.
Okay.
Now, with geometry, a lot of times when you're solving quadratics and you come up with a plus and a minus answer, you throw away the minus answer because dimensions cannot be negative. Does either of these numbers produce a negative dimension? Is x plus 5 negative with either of those answers?
No.
Okay. Is 9x squared plus x plus 1 negative with either of those answers?
And
again, the
how would you be able
answers,
to tell?
again, well, by plugging them in. But if I plug the minus 2/3 in, it gets turned positive. So that's going to be a big positive number. That's going to be a big positive number. In other words, that is still a positive number even when x is minus 2/3. And what that means is both of these answers are valid. If you were taking a test and you didn't list both of these, you'd be deducted at least a point. Okay? Now, since 95% of my students miss that, let's do this problem a different way. Let's subtract 4 from both sides. What's that called? It has a name that you don't ever want to forget. Because if there's one thing math wants you to recognize, it's difference of what? Difference of what?
Of square?
Difference of perfect squares. When I have the difference of perfect squares, a squared minus b squared, it always factors into a minus b times a plus b. Well, that's a squared, that's b squared. So a must be what? If 9x squared is a squared, what's a? It's the square root of 9x squared. Three x times 3x is 9x squared. What's b? B squared is 4. What's b? Mark, did I lose you? You still there? Might have lost you. You back again? Okay, period. I'll talk to you next Tuesday. Bye-bye.